Professor Bialis here. In this video we are going to be talking about section 2.8, which is solving linear inequalities. Up until this point we talked about equations and applications with equations. Simply put, an equation is a statement with an equal sign. An inequality is something that is not equal. Okay? Now when we deal with inequalities, remember when it's not equal, we don't just stop with that, or we don't start and stop with that symbol. We can talk about greater than, less than, greater than or equal to, less than or equal to. These are all inequality symbols. Okay, now a lot of people mix up greater than versus less than. Try to think about the direction that it's pointing. This is pointing to the right, so greater than, left, less than. Okay? Now, before we actually solve these things, we want to know how we're going to write these results. There's something called interval notation. An interval is just a chunk of the number line. Notation is just a way of writing something. Simple as that. So let's start with that discussion. If we're talking about interval notation, let's say we have an inequality, a is greater than 3. Okay? What I like to tell students is to graph this on the number line first. Okay? Now, when we graph on a number line, there's two things. There's marking the key value, and then there's the shading. Now, marking of the key value, when you are given this or this, you are going to mark it with an open dot. Okay? What that means is you get really close to it, but you don't actually include that value. When you have this symbol or this symbol, that's when you use a closed dot to show I get really close and I can include the value itself in my answer. Okay, so in this case, I'm going to put on a 3, and then since there's no or equal to sign, I'm going to have an open dot. Now, in terms of shading, you want to take the shading to be bigger than 3. That variable represents the shading. The shading has to be bigger than 3, so I'm going to go this way. Another kind of trick we use is to say this is pointing this way, so we shade that way. The key thing to remember though is you only do that when the variable is on the left. If the variable's on the right, you can't use that trick. You have to switch it. Okay, so we have an inequality, we graphed it. Interval notation has us write the chunk of the number line that has shading. So if we're going from left to right, we always read books and graphs and everything left to right. We have no shading, no shading, no shading until we hit 3. And then we go on forever. And that's an infinity symbol. Think of that infinity symbol representing that arrow to the right. If we were shading the other way, we would use what's called negative infinity. Okay, and that just tells you the direction that you're going on forever and ever. Now, we have the dot, but we're not going to put a dot with this. Okay, a way to notate this open dot would be parentheses, and when we get to a closed dot, we would use brackets. All that is a way for us to show what we're trying to say. We're just notating it. Okay. So in this case, the 3 has an open dot, we put parenthesis. Now, infinity will always, no matter what, have a parenthesis on it because we can never reach infinity. Okay? Infinity is an idea that we can keep going and going and going, but we can never stop and say, boom, I'm in infinity right here. So no matter what the problem says, infinity will always have a parenthesis on it. And this is your interval notation. All of these things mean the same. It's just a different way of writing it. Simple as that. Let's look at a couple more. How about something like this? Okay. Let's go this way, just so we can kind of mix it up a little bit. I'm going to put on the graph, just so I can get a visualization of what's going on. I have a -4. And then I'm going to use a closed dot because we have this or equal to line. And then I go less than -4. So I'm going to go that way. Now, if I'm reading this left to right, what interval am I shading? I'm starting at negative infinity, and then I'm going all the way to negative 4. Always parenthesis there, and since it was a closed dot, I have a bracket there. What you start seeing once we introduce interval notation is that the open and closed dot kind of go away. And instead of open dot, we put a parenthesis, and instead of a closed dot, we put a bracket. Honestly, it's just preference, okay? As you get into more upper level classes, this is typically what they tend to use, but the open and closed dot is perfectly acceptable. There's nothing wrong with that, okay? So whatever you prefer, stick with it. How about something like this? How about that? Okay, if we were going to graph that on a number line, we have our 12. We have an open dot. Now be careful. Don't look at that and say, oh, it's pointing that way, so I shade that way. The shading should be bigger than the 12. The variable's on the right, so we go the opposite way of where it's pointing. So we're going to be shading that way. Once we get the graph, the interval notation just drops right out. That's why it's so important to take a few seconds and graph, because it makes the interval notation very easy. And we just start with a 12, and we go on to infinity, parenthesis always, open dot parenthesis there. And that's it. That is interval notation, okay? When we get into inequalities, this is typically how we are going to be writing our solutions. So we will be, working through getting to this answer right here. I would suggest graphing. It's not a necessity, but it makes this last step so much easier. So I would take that extra time, graph it, and then write that. Okay? Now let's look at some examples of solving inequalities. Okay, now here's the thing. The 6 steps that we talked about back in section 2 and section 3 with solving equations, the same steps apply here. There's really nothing different. There is one scenario that we have to pay attention to. I'm going to show you that in a little bit here. Okay, but let's go through the 6 steps. First thing, distribute. No clearing fractions, no combining like terms. So I get the variable on one side. Subtract the 2. And that's it. There's nothing more to it than that. Okay? Now, one last thing though is to write this in interval notation. That's kind of the official way of writing these answers. So when I do this, just like I was doing a couple minutes ago, I'm going to draw a number line. Put a 0, open dot, and I go less than 0, negative infinity to 0. Simple as that. Okay, so this is your final answer that we would be looking for. The solving is very easy, same as before. It's just added a little bit with the graph and the interval notation. Now, I want to go over a very simple example just to illustrate something here. Okay, now if we were to solve that, do what we normally would do. I would divide by a negative 3, and I got that. Now here's the problem. Why is that wrong? What I should have done is flip that over. Okay, here's the rule. When you multiply or divide both sides of an inequality by a negative, flip the inequality symbol. Again, when you multiply or divide both sides of an inequality by a negative, flip the inequality symbol. That's the rule. Why do we do that? The reason being, if I have, let's say, a 3 and a 5, I'm just picking random 3 and 5. If we look at that comparison, 5 is bigger, correct? Yeah, it's bigger. However, if I were to multiply both sides, let's say by a -1, okay? When I divide both sides by a -3 here, I change the sign on both sides. If I change the sign on both sides here, now which is bigger? Now the smaller number is bigger when you're dealing with negatives. Okay, so by moving that negative on both sides, I change the relationship, so I have to change the inequality symbol. So that is the only added little bit that we have to pay attention to with inequalities versus equations. Everything else, same thing. Okay, to finish this up, put a -3, close dot, and since I made the switch, I'm going this way, -infinity to -3, parenthesis, bracket. Okay? Let's look at something a little different. Okay, I still want you to solve, but now I'm going to give you something like this. Now, what the heck is that? That is what's called a compound inequality. You'll talk about that a little bit more in chapter 9 in more detail when we get there. But right now we're just going to keep this simple. Okay? What we basically have are two inequalities in one. We have this inequality here and that inequality there. It's just they interact with one another in a certain way that we can pull it together in one clean statement. Now, in these compound inequalities, I want you to always look for this growth from left to right. I start on a low end of 5 and I get bigger, bigger, bigger to 11. Okay? You never want to switch that or have, something like this. That wouldn't work in this format. Okay? It always has to be increasing from left to right. Now, when we solve this, we solve it like we would any other inequality. What you do to one side, you do to the other. It's just here we got three sides. What I tell students is if you're looking at it and saying, I don't know where to start, there's so much to do, okay? Cover that up for a second. How would I solve that? I would subtract 1, but now if I do it to one side, I do it to all three. I didn't erase that, I just covered it up. The way I solve that is the way I solve this. And I've got 4 less than 2x less than or equal, to 10. Okay, same thing. How would I solve that? I would divide by 2. Do the same thing there. 2 less than x less than or equal to 5. When are you done? When the variable's alone in the middle. Okay, now what about the interval notation? Now, don't overthink this situation right here. If you have those three-sided inequalities, that variable and that shading is always in the middle. Okay, the variable and the shading are one and the same. They're always in the middle. So I'm going to go from a low end of 2, high end of 5. 2 has the open dot on it. 5 has the closed dot on it. And I'm shading in between because I want to be bigger than 2 but smaller than 5. And that's right in this region here. The interval notation is not going to have infinities on it because these are not shaded. I'm not going on forever. Left to right, I go 2 to 5. Parenthesis for the open dot, bracket for the closed dot. And here's your interval notation. Let's do one more like that. How about that? Again, if you have to, how would I solve that? You have a couple options. You could move the 5 or you could clear the fraction first. It is completely up to you. I'm going to clear the fraction. So I'm going to multiply every term by 4. But don't forget, I still have that. Covering that up doesn't throw it out. It just helps you visualize a simpler problem. And what we get is a 4 less than 3x plus 20 less than 24. Going from there, how would I solve that? I would subtract 20. I have negative 16 less than 3x less than 4. How do I solve that? Divide by 3. Don't forget that last one. And I've got negative 16 over 3. I wouldn't do anything with that. Less than x less than 4/3. X is by itself. We're done. Now, where is that shading? It goes from negative 16/3 all the way to 4/3, both of them with an open dot. So our answer is negative 16/3 to 4/3 parentheses on both. Now we got to be careful. Those of you who remember graphing, we're going to get to that in chapter 3, but it's very easy to misinterpret this as an ordered pair on a graph grid. That's not what's happening here. We're looking at this as an interval on a number line, so just be careful with that distinction. The only thing really to worry about here and to focus on is that idea of when we multiply or divide both sides by a negative, the inequality symbol has to change. Otherwise, solve an equation like we always have, and then we have the interval notation. Graphs are optional. I highly recommend them though. Okay? So, as always, work hard. Let me know if you have any questions, and I'll see you next time.